Hello and a warm welcome to everyone joining us today. I hope you're having a fantastic day so far. Today we are going to dive into an exciting topic, how DDI solutions optimize healthcare networks. In this webinar, we'll explore how a DDI solution can significantly enhance the efficiency, reliability, scalability, security, and manageability of network infrastructures in healthcare settings. Very quick introduction. I'm your host, Akshara GJ, product expert from ManageEngine. I collaborate closely with the marketing teams for ManageEngine, DDI Central, and Cloud DNS. A big part of what I do is talk about the critical network services like DNS, DHCP, and IPAM. I'm here to share insights on how DDI solutions can significantly enhance healthcare network infrastructures. For the agenda today, first up, we'll understand the demands of modern healthcare networks. Moving on, we'll explore how you can gain holistic visibility and control over a hospital's core network services across local and remote sites using a DDI solution. Following that, we'll delve into the strategic importance of network segmentation in healthcare networks. Then we'll proceed to discussing how IPAM acts as the network source of truth to support the dynamic operations involving the three core services of a healthcare network. We'll then see how zero-touch provisioning can dramatically streamline the management of IoMT devices or Internet of Medical Things within a hospital network. Following that, we'll explore how to leverage real-time analytics to monitor and identify security issues and resource availability thresholds. Next, we'll discuss how DDI solutions ensure high availability through auto-failover setups for core network services. Lastly, we'll cover how DDI solutions provide in-depth defense to a hospital network against unwanted intrusions. Look at the image here. This is how a typical healthcare network ecosystem operates. Healthcare organizations today have embraced new operational models revolving around delivering real-time healthcare services from emergency response coordination to routine consultations that span distant locations. To support such demands, healthcare organizations seek private vans to connect main hospital sites with their extensive network of branch hospitals, data centers, and remote healthcare facilities. With frequent changes required in healthcare networks, like connecting new sites or launching new services, these healthcare facilities often focus on infrastructure upgrades. However, converging and managing them on a common IP infrastructure remains challenged. Smart healthcare has been revolutionizing how we approach patient care and medical management. However, as technology continues to integrate deeper into healthcare networks, managing these complex systems becomes increasingly challenging. So here are the four key challenges. First, reliable connectivity. The foundation of any smart healthcare system is its ability to maintain continuous and reliable network connectivity. This is crucial not just within hospital walls, but also extends to remote healthcare facilities. Second, security. As healthcare systems integrate more digital solutions, they become prime targets for cyber attacks. The stakes are high as security breaches can lead to compromised patient data and interrupted healthcare services. Third, compliance and privacy. The healthcare industry is heavily regulated with stringent requirements for data privacy and security. Upholding these regulations, such as HIPAA, GDPR, and other global standards consistently and effectively, is not just about legal compliance, but also about preserving the trust of patients and stakeholders. Fourth, data management and integration. Data from network services often exists in silos, each operating independently without intercommunication. This isolation prevents healthcare networks from aligning different data points to derive comprehensive, actionable insights and harness the full potential of the information at their disposal. As you can see on the slide, in 2023, Infoblox's research on healthcare data breaches revealed that about 78% of the breaches caused by hacking or IT incidents involved data that was compromised from just network servers. This percentage is not just a number, it highlights a significant vulnerability breeding in healthcare network infrastructures. Let's see what are the demands of modern healthcare networks. Healthcare networks must be capable of expanding or contracting based on the demand for medical services. This scalability ensures that network resources can accommodate sudden surges in telehealth traffic, IoMT devices, or integrate new facilities and technologies without disruption. The ability to dynamically allocate network resources where and when they are required is crucial for healthcare networks. This agility helps healthcare providers enhance their responsiveness and ensures high quality patient care through uninterrupted access to medical applications and data. Modern healthcare networks require real time monitoring to ensure network health and to preemptively identify and address potential issues before they impact services. Real time analytics also play a pivotal role in optimizing network performance and in making data driven decisions to improve patient care delivery. Given the sensitivity of patient data, healthcare networks require robust, multi-layered security strategies to protect against both external and internal threats. This includes everything from advanced threat detection and response systems to regular security audits and compliance checks. Complete visibility into the network is essential for identifying and mitigating risks before they escalate. What is DDI? DDI is a comprehensive network management solution that unifies three core network services: DNS, DHCP, and IPAM. It enables you to take complete control and gain holistic as well as deeper visibility into the configurations of these three services. With a DDI solution, you can easily define and manage scopes, dynamically lease IP addresses to hosts, set up custom DHCP fingerprinting policies, manage DNS zones, views, and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all through a single window. What if I told you that this one window solution can also serve as a single point of management for all your internal and remote healthcare sites? Yes, with a DDI solution, you can easily manage the DNS, DHCP, and IPAM configurations of each remote healthcare facility already connected to your main hospital network. Using advanced technologies like SD-WAN, MPLS core via VPN, or even dark fiber cables. This way, the hospital network administrators can holistically view and centrally manage the core network services of different remote healthcare facilities associated with the main hospital, all from a single window. Let's see how this is possible with ManageEngine's own DDI solution, DDI Central. So in DDI Central, you can manage each healthcare facility as a separate cluster. Each cluster comes with its internalized IPAM and can be managed independently of other clusters. All you have to do is add your DNS and DHCP servers to each cluster and discover their configurations and manage them from a unified window. You can just choose the cluster of your choice and monitor the health and performance of its core services in real time. So this is how you can seamlessly scale as your healthcare network facilities grow using DDI Central. So let's now focus on a crucial defensive strategy in network management, which is network segmentation. Let's see why segmenting your healthcare network is not just an operational tactic, but a strategic necessity in today's cybersecurity landscape. Segmentation provides detailed visibility into a DHCP scope, its inventory, objectives, and policies in the form of DHCP options and tighter control over the configurations. This granular this granular view is critical for identifying and responding to suspicious activities quickly. Network segmentation guides your network administrators where to look at in the event of an incident or capacity exhaustion. In the event of a security breach, segmentation helps contain the impact to a limited area, preventing the spread of harmful effects across the entire network. Advanced scope monitoring with defined segments provides network administrators with a visual breakdown of IP addresses within the scope based on their availability status, capacity thresholds, ensuring effective capacity planning and resource optimization. Custom policies for address pools within subnets allow for specific security and access policies tailored to the needs of different host groups within the same department, enhancing both security and operational efficiency. Segmentation also offers flexible configuration options for each scope, which means networks can be tailored to meet specific functional requirements or regulatory compliance needs. By grouping different subnets into shared networks, we can club multiple non-consecutive or unrelated scopes and treat them as a single entity to apply custom policies collectively. You can reduce the scope of compliance by reporting the audits of only those segments to the regulators instead of the whole network. This is how we segment the DHCP scopes in DDI Central using the DHCP scope manager. So for DHCP scope is nothing but a range of IP addresses. So you can segment the IP address ranges in as subnets, supernet, shared network, and VLAN. Subnets constitute the basic building blocks of your network infrastructure. So within a subnet, you can define different address pools and give them different objectives and policies in the form of DHCP options, or you can also define custom DHCP options. Supernet is mainly used as an administrative feature where you can hierarchically organize the subnets under a supernet. So the end result would be a tree view where you can view where each subnet lies in the hierarchy. So this helps your network administrators to where to look at and identify the subnet they are searching for and work on it. So the shared network is a bunch of subnets put together, and this group is treated as a single entity and you can apply custom policies to it. So with VLAN, you have isolated DHCP scopes where this broadcast domain with the DHCP server is totally isolated from the other DHCP broadcast domains, and this is only meant for administrative purposes. So while discovering the configurations, the VLANs and the supernet go undiscovered. So you'll have to configure it on your own when you get into DDI Central. So this is how subnet, shared network, and host or fixed addresses are configured inside DDI Central. So you can define the IP address pools and give certain DHCP options or custom options for it and decide the DHCP server that is going to serve this particular subnet. You can assign each subnet a VLAN. So VLANs are basically logically constructed upon each subnet. So yeah, for shared networks as well, you can apply collective policies for all the subnets that are coming under this shared network. So this is how the scopes are segmented in DDI Central. So with well-defined scopes, you can monitor the IP address inventory within each scope. So you'll get to see a donut plot which provides a visual breakdown of the number of IP addresses in the subnet according to their availability status. The number of available IP addresses, active IP addresses, abandoned IP addresses, fixed IP addresses, and free available IP addresses. So you can get to see the subnet usage percentage. You can effectively view the capacity thresholds of each subnet before it goes into exhaustion. DDI Central also offers you domain query analytics. So when you get into the analytics page of the DNS module, you'll get to see the query traffic of a particular domain. So you'll get to see a separate donut chart providing you a visual breakdown of the query volume for different types of DNS records configured under the domain name, illustrating the distribution of each query type. So you can also see the number of IP addresses that were accessing this particular domain, and you can see the total queries coming from each IP. Network segmentation can also be achieved using DNS. So for achieving network segmentation, we use a special feature called domain views. Views are special features through which you can implement network segmentation. It enhances protection against potential threats by customizing DNS responses, enforcing distinct security policies, and controls access for different user groups and network segments within your healthcare facility. So let's consider a scenario where a client requests for a zone endocrinology.zilkahospitals.com. So when this query reaches the DNS server finds that this particular domain has two views configured, the internal view and the external view. The internal view is meant only for the healthcare givers, and the external view is meant for all stakeholders. There's no restrictions for it. So for this internal, first it checks for a match in the internal view. So it checks the client IP if it is listed in the allow list of the internal view. So if the match is not found, it shifts its focus to the external view where it finds that there is no restrictions here for any IP. So it just searches for under this domain name and locates this particular zone that the client requested for. So on locating this particular zone under this domain name, zilkahospitals.com, it confirms the query handling for zilkahospitals.com and delivers the response from the external view to the back to the client. So this is how the domain views work. DDI Central captures audit trails for every action executed on each and every object managed by the DNS and DHCP servers. You can choose the relevant subnets or zones and report the audits of only those segments to the regulators. This saves time and reduces costs compared to reporting full network audits. With the DDI solution in place, data from all the three core network services are not only collected but also correlated and analyzed in one central hub. In a DDI solution like DDI Central, IPAM serves as the centralized and contextualized network source of truth that map upstream relationships among the core services. As you can see in the image, behind the lease history of a particular IP, you get to see how it has captured the DNS records, DHCP lease information, and IP address allocations to various hosts within the network. This unified approach allows for a holistic view of network operations, enabling healthcare providers to make timely and informed decisions based on comprehensive data analysis. This information aids in quick troubleshooting, optimizing resource allocations, and maintain network stability. This kind of data triangulation makes DDI a sophisticated automation hub for healthcare networks. As it becomes easy to set up end-to-end automation involving these services, DDI Central serves as an automation hub. So here are some of the key processes that can be automated using DDI Central. Using DHCP server, you can automatically assign IP addresses to hosts on the network. This enhances the efficiency of network resource management and ensures that IP addresses are reclaimed and reused appropriately, reducing wastage and preventing address exhaustion. The dynamic DNS feature updates the DNS records automatically when an IP address changes, ensuring that the network resources are always accessible via their host names. This is crucial in healthcare settings where device mobility and configuration changes are frequent, necessitating real-time updates. DDI systems automatically detect and resolve IP address conflicts and maintain an updated IP address inventory, ensuring reliable connectivity and preventing downtime in healthcare operations. Scheduled creation of DHCP scopes and DNS records allow network administrators to plan and implement network expansions or updates at predetermined times for maintaining uninterrupted service during operational hours. DDI solutions offer built-in automated failover setups for DNS and DHCP services that guarantee business continuity in the event of infrastructure failure in healthcare networks. Let's delve on high availability of DNS and DHCP services. So we'll be exploring how DDI Central implements auto-failover setups for DNS and DHCP services. In DDI Central, for DHCP servers, while configuring a subnet, you can add one primary DHCP server and add as many secondary DHCP servers. In case the primary DHCP server fails, the secondary server comes to the fore and handles the traffic. If you want these servers to split the load, you can enter the relevant value in the split field. A value of 128 here indicates 50-50 load balancing, actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, while configuring a domain, you can add multiple primary DNS servers for the domain. Subsequently, DDI Central also accepts a list of multiple secondary servers to facilitate reliable access to resources across a healthcare network. IoMT, or Internet of Medical Things, is a critical component of modern healthcare networks. Previously, devices were beyond the network's tracking capabilities, but now these devices are IP enabled and can be tracked and provisioned automatically without manual intervention. As illustrated in the diagram here, the IoMT ecosystem is vast and interconnected, adding more complexity to the healthcare networks. These devices require custom policies, and it would not be wise to manage them in a separate address space given their dependency and connectivity with other devices in the network. To address this, we train the DHCP server to extract the device details, recognize these devices using DHCP fingerprinting policies, and apply custom policies without isolating these devices from the network. To achieve zero-touch provisioning of IoMT devices, we incorporate PXE or pre-boot execution environment configurations. With PXE configurations, the DHCP server does all the heavy lifting in provisioning boot files, configuration files, or other supplementary files as soon as an IoMT device connects to the network. Using PXE configurations, the DHCP server directs the IoMT devices to the TFTP server in your network. TFTP server ensures that these files are centrally managed and deployed, significantly simplifying the process of updating and maintaining a large fleet of devices scattered across multiple locations. For IoMT devices, the files transmitted via the DHCP server under PXE configurations are optimized to include only necessary components to perform their specific functions. This can include lightweight operating systems, specific security updates, and customized applications designed for minimal resource consumption and rapid boot times. As you can see on the screen, we've created a client class that is programmed to recognize devices based on their vendor profile. In the conditional statement, we've specified if the device belongs to a specific type of architecture using an architecture code, it receives a certain file path. If you see below in the DHCP options section, you'll find a DHCP option configured. With this option called Next Server, the DHCP server directs the devices that match the criteria to a TFTP server. All this can be automated by our DHCP server for hundreds and thousands of IoMT devices as soon as they are plugged into your network without any manual intervention. This is actually a one-time configuration. You don't have to repeat it for every set of new devices joining your network. Configure it once. With these instructions in place, every time a new IoMT device is plugged into your network, the targeted configurations would be applied for that device. As DNS is the first point of contact across external networks, the DNS firewall constitutes the network's first line of defense. Following a layered approach, it places strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response rate limiting feature. So let's see how DNS firewall works. Consider a scenario where a healthcare provider from your hospital, after using public free Wi-Fi at a cafe or an airport, unknowingly gets his or her system infected by a malware. Upon connecting to your healthcare network, the malware covertly accesses malicious sites. DDI Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against this blacklist. If there is a match on the blacklist, the resolver does not proceed to fetch the real IP address from the external authoritative DNS server. Instead of connecting to the malicious site, the user is directed to a safety page. Let's see how domain blocking is implemented in DDI Central. In DDI Central, you can just enter the malicious sites one by one, or you can import them in bulk using a CSV file. We've already configured various categories for various categories of malicious domains. You can choose the category of your choice for your industry, and then you can import them into the block list. So when you add a domain into the block list, you can also choose block subdomains, which blocks all the subdomains associated with a malicious domain. We do not know how many subdomains exist for that malicious site. So you can choose this option to block all the subdomains belonging to that particular domain. So we have the redirection IP here. You can just enter the redirection IP. So this is the IP address that your user is going to be redirected to when they try to access this malicious domain. So this is how you can block malicious domain using DDI Central. Now, domain blocking is actively functioning, and you will be curious to know who's accessing all these malicious sites. So how can you identify the end user who's actively accessing these malicious sites? So the DNS analytics page in DDI Central also displays the query analytics for every block domain accessed via the resolvers of your network. Here you can see who accessed what type of records pertaining to the block zone under which IP, and specifies the details about their identity like their host name and the time of access. This way, the admin can quickly identify the host violating such network security policies. Also, DDI Central gives an overview of the list of IPs trying to reach the said blocked zones and a visual snapshot of the same to identify the major actors involved in the security violation act. So with this quick snapshot, your network admins can identify the host and quarantine the end user before it spreads over the whole network. Now let's dissect a common cyber attack scenario involving a botnet and discuss the defensive strategies that can be employed using a DDI solution. At the core, we have the botnet command center targeting a particular victim network in your healthcare infrastructure. It keeps sending instructions to compromised endpoints called botnets. These botnets then execute the attack by sending malicious queries to the DNS servers using the IP address of the victim. This is known as IP spoofing. The DNS servers in your healthcare network, unaware of the deception, respond to these queries. However, due to the nature of the attack, these responses are not just simple replies. They are massively amplified, meaning a small query triggers a large response. The final target of this onslaught is the victim network in your healthcare facility. The amplified responses flood the victim's network, potentially overwhelming it with data and causing significant disruption. This type of attack is known as distributed denial of service attack or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in Harley query traffic, indicating a DDoS attack in progress. To mitigate the DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks. The response rate limiting in a DNS is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well-balanced approach to security. When a DNS server starts receiving similar type of queries from the same IP or a client, the DNS server with response rate limiter configured checks the rate of the requests coming from this particular client. The rate limiter's job is to determine whether this frequency of requests exceeds predefined thresholds, which are set to prevent abuse and to manage server load effectively. If the rate limit is exceeded, the server will send a throttled response back to the client. However, if the rate of the request is within the acceptable limits, the DNS server will proceed to send the appropriate DNS response to the client. This selective response mechanism ensures that your network is not only resilient against attacks, but also remains efficient and reliable for legitimate users. So how do you contain threats that has already penetrated into a particular scope or a subnet? By segmenting a network into scopes, you isolate each segment from the rest of the network. This limits the potential impact of a security breach, as attackers have access to only a portion of the network they've penetrated into, rather than the entire network infrastructure. Segmenting the scopes into subnets and VLANs help contain the damage by isolating the affected subnet, allowing administrators to more effectively control the spread and mitigate risks. Subnetting also reduces network-wide threats by quarantining compromised areas and hindering unauthorized lateral movement within the network. So here's an interesting use case scenario. Let's see how a hospital provides round-the-clock radiology services across remote healthcare facilities using DDI Central. Patient with a head injury arrives at the emergency room of a regional healthcare facility at 3 a.m. after a fall and receives a CT scan. While the patient is being cared for in the emergency room, his CT scan is being viewed by a radiologist working from the main hospital. The radiologist needs to consult with a specialty musculoskeletal radiologist who is working at one of the branches of the main hospital. Now, the challenge here is both radiologists need to view the same study and consult with each other while working from different locations to arrive at a diagnosis for the emergency room physician. Now, both radiologists want to connect their laptops to the regional healthcare facilities private imaging network, which is typically a private LAN isolated from the public network and connected to it only through firewalls. This private network has its own DNS and DHCP clusters. The facility hosts the web-based software that displays the image only to the clients that possess the IP addresses from a specific subnet within the regional healthcare facilities IP address space. So what's the solution here? To ensure the radiologists have real-time access to the web-based image viewing software, we need to establish special constructs called client classes that enable DHCP servers to identify their laptops by their unique MAC addresses and immediately assign them an IP address from a dedicated subnet within the private network. So let's see how to implement this in DDI Central. First, we create a client class on the DHCP server of the remote healthcare site, just like the one you see on screen. Let's have a look at the configurations here. We see for the match type, the substring option is chosen to tell the DHCP servers to search for a specific sequence of characters within the client's DHCP messages. The offset field is used to designate where this search should begin within the DHCP message. Since we want the search to begin from the very first character, we've entered the value 1 for the field. For the length field, we've given the value 17, which corresponds to the length of a MAC address. Enter hardware in the match string field, guiding the DHCP server to recognize and extract hardware address from the packet. Since our goal is to match specific MAC addresses, each radiologist's MAC address has been added as match value. Now, this client class must be associated with the appropriate subnets within the remote healthcare facilities network. This way, the DHCP server, following the client class policies, permit only devices with those specific MAC addresses to connect and collaborate over the remote healthcare network. As we wrap up this webinar, it's clear that the DDI solution unifying DNS, DHCP, and IPAM serves not just as a technological foundation, but also as a strategic enabler for modern healthcare networks. Today, we've seen how integrating DDI solutions into healthcare networks propels hospitals towards digital excellence by ensuring reliable network uptime, which is critical in life-saving situations. It secures connections across various facilities and safeguards patient data against the ever-growing threats in cyberspace. By optimizing network operations and security, DDI enables a future where healthcare delivery is both efficient and secure. This transformation goes beyond mere operational improvements. It enhances the patient experience and fortifies their trust in smart healthcare facilities. Our journey towards a more connected and secure healthcare system is ongoing, and DDI stands at the forefront of this evolution. So we've come to the end of the session. Thank you for taking the time to be part of this webinar. Here's a support email ID. If you have any queries, please shoot us a mail at ddisupport@manageengine.com. This is Akshara signing off. Thank you.